At the end of this topic, you will be able to define the terminologies used in the metallurgy, state the differences between minerals and ores, explain the occurrence of copper, aluminium, and iron, explain the extraction of copper, aluminium, and iron, state uses of copper, aluminium, and iron, give the properties of copper, aluminium, and iron. Metallurgy is as old as our civilization. Metals play a significant role in our life. They constitute the mineral wealth of a country, which is the measure of prosperity. Silver is a white metal to build aircraft. Iron is lustrous steel to make machineries and bridges. Copper is a reddish-brown metal to make coins. They all unite together to form alloys. Copper was the first metal to be used for making utensils, making weapons, and for other works. Metals are of two types. Metals like titanium, chromium, manganese, zinc-corium, etc. find their applications in the manufacture of defense equipments. These are called strategic metals. The metal uranium plays a vital role in nuclear reactions, releasing enormous energy called nuclear energy. Copper, silver, and gold are called coinage metals as they are used in making coins, jewelry, etc. The vitality of metals for the totality of life. Metals in minute amounts are essential for various biological purposes. Fe, a constituent of blood pigment, hemoglobin. Ca, a constituent of bone and teeth. Co, a constituent of vitamin B12. Mg, a constituent of chlorophyll. Purity of gold is expressed in carats. 24 karat gold is equal to pure gold. For making ornaments, 22 karat gold is used, which contains 22 parts of gold by weight and 2 parts of copper by weight. The percentage of purity is 22 by 24 into 100 is equal to 91.6%. 916 make gold. From 1 gram of gold, nearly 2 kilometers of wire can be drawn. Minerals. A mineral may be a single compound or complex mixture of various components of metals which are found in the earth. Ores. The minerals from which a metal can be readily and economically extracted on a large scale is said to be a ore. For example, clay, Al2O3.2SiO2.2H2O, and bauxite, Al2O3.2H2O, are the two minerals of aluminium. But aluminium can be profitably extracted only from bauxite. Hence, bauxite is an ore of aluminium and clay is its mineral. Difference between minerals and ore. Minerals, it contains low percentage of metal. Ores, it contains high percentage of metal. Minerals, metals cannot be extracted from minerals. Metals can be extracted from ores. All minerals are called as ores. All ores are not minerals. Mining. The process of extracting the ores from the earth crust is called mining. Metallurgy. Various steps involved in the extraction of metals from their ores as well as refining of crude metal are collectively known as metallurgy. Gangue or matrix. The rocky impurity associated with the ore is called gangue or matrix. Flux. It is a substance added to the ore to reduce the fusion temperature. Slag. It is a fusible product formed when flux reacts with gangue during the extraction of metals. Flux plus gangue gives slag. Smelting. Smelting is the process of reducing the roasted oxide to metals in the molten condition. Metals which have low reactivity are found in either free state or native state. Nearly 80 metallic elements are found from the minerals and on or under the surface of the earth. Gold, silver, and platinum are examples of metals that are found in a free state. Most of the other metals are found in a combined state in the form of their oxide ores, carbonate ores, halide ores, sulfide ores, sulfate ores, and so on. The ores of metals found in the native state are as follows. Oxide ores: bauxite, Al2O3.2H2O, cuprite, Cu2O, hematite, Fe2O3. Carbonate ores: marble, CaCO3, magnesite, MgCO3, siderite, FeCO3. Halide ores: cryolite, Na3AlF6, fluorspar, CaF2, rock salt, NaCl. Sulfide ores: galena, PbS, iron pyrite, FeS2, zinc blende, ZnS. Metallurgy is the entire process of obtaining or extracting a pure metal from its ore and is comprised of three main operations: concentration of ores, conversion of contrite to oxide, and refining of metals. The flow chart represents the steps involved for the extraction of metals from its ores based on the reactivity. Metals of high reactivity, metals of medium reactivity, and metals of low reactivity. Symbol Al. Color silvery white. Atomic number 13. Ec283. Valency 3. Atomic mass 27. Occurrence of aluminium. Aluminium is a reactive metal and found in nature as a combined form. The main ores of aluminium are bauxite, Al2O32H2O, cryolite, Na3AlF6, corundum, Al2O3. Extraction of aluminium from bauxite. The chief ore of aluminium is bauxite and its extraction involves two stages: conversion of bauxite into alumina and electrolytic reduction of alumina. The conversion of bauxite into alumina is done by Bayer's process. Bauxite ore is finely grounded and heated under pressure with concentrated caustic soda solution at 150 degrees Celsius to obtain sodium metaaluminate. Al2O3 2H2O plus 2NaOH at 150 degrees Celsius reacts to give 2NaAlO2 plus 3H2O. On diluting sodium metaaluminate with water, aluminium hydroxide precipitate is obtained. NaAlO2 plus 2H2O gives NaOH plus AlOH3. The precipitate is filtered, washed, dried and ignited at 1000 degrees Celsius to get alumina. 2AlOH3 gives Al2O3 plus 3H2O. The electrolytic reduction of alumina is done by Hall's process. Aluminium is produced by the electrolytic reduction of fused alumina Al2O3 in the electrolytic cell. Cathode. Ion tank lined with graphite. Anode. A bunch of graphite rods suspended in molten electrolyte, pure alumina plus molten cryolite plus fluorospar. Fluorospar lowers the fusion temperature of electrolyte. Temperature 900 degrees to 950 degrees Celsius. Voltage used 5 to 6 volts. The overall reaction for aluminium extraction is 2Al2O3 gives 4Al plus 3O2. Aluminium deposits at cathode and oxygen gas is liberated at anode. Physical properties. It is a silvery white metal. It has low density and it is light. It is malleable and ductile. It is a good conductor of heat and electricity. Melting point is 660 degrees Celsius. It can be well polished to produce attractive shiny appearance. Chemical properties. Reaction with air. It is not affected by dry air. On heating at 800 degrees Celsius, aluminium burns very brightly, forming its oxide and nitride. 4Al plus 3O2 gives 2Al2O3, aluminium oxide. 2Al plus N2 gives 2AlN, aluminium nitride. Reaction with water. Water has no reaction on aluminium due to the layer of oxide on it. When steam is passed over red-hot aluminium, hydrogen is produced. 2Al plus 3H2O gives Al2O3 plus 3H2. Reaction with alkalis. It reacts with strong caustic alkalis forming aluminates. 2Al plus 2NaOH plus 2H2O gives 2NaAlO2 plus 3H2. Reaction with acids. With dilute and concentrated HCl, it liberates H2 gas. 2Al plus 6HCl gives 2AlCl3 plus 3H2. Aluminium liberates hydrogen on reaction with dilute sulfuric acid. Sulfur dioxide is liberated with hot concentrated sulfuric acid. 2Al plus 3H2SO4 gives Al2SO43 plus 3H2. 2Al plus 6H2SO4 gives Al2SO43 plus 6H2O plus 3SO2. Dilute or concentrated nitric acid does not attack aluminium, but it renders aluminium passive due to the formation of an oxide film on its surface. Reaction with reducing agent. Aluminium is a powerful reducing agent. When a mixture of aluminium powder and iron oxide is ignited, the latter is reduced to metal. This process is known as aluminothermic process. Fe2O3 plus 2Al gives 2Fe plus Al2O3. Uses of aluminium. Household utensils. Aluminium metal. It is light, cheap, corrosion resistant and good conductor of heat. Electrical cable industry. Aluminium wires. It is a good conductor of electricity. Aeroplanes and other industrial parts. Dura-alumin, AlCuMgMn, magnesium, AlMg. Its alloys are light, have high tensile strength and are corrosion resistant. Thermite welding, Al powder, AnFe2O3. Its powder is a strong reducing agent and reduces Fe2O3 to iron. Symbol Cu. Atomic number 29. Ec 28181. Valency 1 and 2. Atomic mass 63.55. Occurrence of copper. Copper is found in native state as well as combined state. Romans called copper as cuprum because they used to get it from the island of Cyprus. The ores of copper and its formula is given in the table. Copper pyrite CuFeS2. Cuprite or ruby copper Cu2O. Copper glance Cu2S. The chief ore of copper is copper pyrite. It yields nearly 76% of the world's production of copper. Extraction of copper from copper pyrites. It involves the following stages: crushing and concentration, roasting, smelting, bessemerization, and refining. Stage 1. The ore is crushed and concentrated by froth flotation process. Stage 2. The concentrated ore is roasted in excess of air. During roasting, that is, moisturizer and volatile impurities are removed. Copper pyrite is partly converted into sulfides of copper and iron. 2CuFeS2 plus O2 gives Cu2S plus 2FeS plus SO2. Stage 3. The roasted ore is mixed with powdered coke and sand and is heated in a blast furnace to obtain matte and slag. The slag is removed as a waste. Matte is equal to Cu2S plus FeS. Stage 4. The molten matte is transferred to Bessemer's converter in order to obtain blister copper. Ferrous sulfide from matte is oxidized to ferrous oxide, which is removed as slag using silica. 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2. 2Cu2O plus Cu2S gives 6Cu plus SO2. FeO plus SiO2 gives FeSiO3. Stage 5. Blister copper contains 98% pure copper and 2% impurities and are purified by electrolytic refining. This method is used to get metal of high degree of purity. Cathode. A thin plate of pure copper metal. Anode. A block of impure copper metal. Electrolyte. Copper sulfate solution acidified with sulfuric acid. When electric current is passed through the electrolytic solution, pure copper gets deposited at the cathode. Impurities settle at the bottom of the anode in the form of sludge called anode mud. Physical properties of copper. It is a reddish-brown metal. It has high luster. It has high density. It has high melting point, 1356 degrees Celsius. Chemical properties of copper. Reaction with air and moisture. Copper in the presence of CO2 and moisture gets converted with the green layer of basic copper carbonate. 2Cu plus O2 plus CO2 plus H2O gives CuCO3 CuOH2. Reaction on heating. On heating at different temperatures in the presence of oxygen, it forms two types of oxides, CuO, Cu2O. 2Cu plus 2O2 gives 2CuO. 4Cu plus O2 gives 2Cu2O. Reaction with acids. Dilute acids such as HCl and H2SO4 have no action on these metals in the absence of air. Copper dissolves in these acids in the presence of air. With diluted HCl, 2Cu plus 4HCl plus O2 in the presence of air gives 2CuCl2 plus 2H2O. 2Cu plus 2H2SO4 plus O2 gives 2CuSO4 plus 2H2O. Copper reacts with dilute HNO3 with the liberation of nitric oxide gas. With dilute HNO3, 3Cu plus 8HNO3 diluted gives 3CuNO32 plus 2NO plus 4H2O. Copper reacts with concentrated HNO3 and concentrated H2SO4 with the liberation of nitrogen dioxide and sulfur dioxide respectively. With concentrated HNO3 and concentrated H2SO4, Cu plus 4HNO3 gives CuNO32 plus 2NO2 plus 2H2O. Cu plus 2H2SO4 gives CuSO4 plus SO2 plus 2H2O. Reaction with chlorine. Chlorine reacts with copper resulting in the formation of copper 2 chloride. Cu plus Cl2 gives CuCl2. Reaction with alkalis. Copper is not attacked by alkalis. Iron is the second most abundant metal after aluminium. Symbol Fe, color grayish white, atomic mass 55.9, atomic number 26, valency 2 and 3, electronic configuration 2, 8, 14, 2. Iron occurs in nature as oxides, sulfides and carbonates. The ores of iron and its formula is given in the table below. Red haemite Fe2O3, magnetite Fe3O4, iron pyrites FeS2. The extraction of iron from hematite involves three stages: concentration, roasting and calcination, and smelting. Stage 1. The powdered ore is washed with stream of water by gravity separation process. As a result, the lighter sand particles and other impurities are washed away and heavier ore particles settle down. Stage 2. The concentrated ore is strongly heated in a limited supply of air in a reverberatory furnace. As a result, moisture is driven out and sulfur, arsenic, phosphorus impurities are oxidized off. Stage 3. The roasted ore is smelted along with coke and limestone in the ratio 8:4:1 in a blast furnace by introducing it through the cup and cone arrangement at the top. Blast furnace consists of three regions. The lower region, combustion zone. In this region, coke burns with oxygen to form CO2 when the charge comes in contact with a hot blast of air. C plus O2 at 1500 degrees Celsius gives CO2 plus heat. The middle region, fusion zone. In this region, CO2 is reduced to CO at 1000 degrees Celsius. CO2 plus C at 1000 degrees Celsius gives 2CO. Limestone decomposes to calcium oxide and CO2. CaCO3 on heating gives CaO plus CO2. These two reactions are endothermic due to the absorption of heat. Calcium oxide combines with silica to form calcium silicate slag. CaO plus SiO2 gives CaSiO3. The upper region, reduction zone. In this region, carbon monoxide reduces ferric oxide to form a fairly pure spongy iron. The molten iron is collected at the hot dome of the furnace after removing the slag. Fe2O3 plus 3Cu at 400 degrees Celsius gives 2Fe plus 3CO2. The iron thus formed is called pig iron. It is remelted and cast into different molds. This iron is called cast iron. Calcination. It is a process in which ore is heated in the absence of air. As a result of calcination, the carbonate ore is converted into its oxide. Roasting. It is a process in which ore is heated in the presence of excess of air. As a result of roasting, the sulfide ore is converted into its oxide. Properties of iron. It is a heavy metal of specific gravity 7.9 grams per cc. It is a lustrous metal and grayish-white in color. It has high tensility, malleability and ductility. It is a good conductor of heat and electricity. It can be magnetized. Chemical properties of iron. Reaction with air or oxygen. On heating in air, iron forms magnetic oxide. 3Fe plus 2O2 gives Fe3O4. Reaction with moist air. When iron is exposed to moist air, it forms a layer of brown hydrated ferric oxide on its surface. This compound is known as rust, and the phenomenon of forming this rust is known as rusting. 4Fe plus 3O2 plus 3H2O gives 2Fe2O3 3H2O. Reaction with steam. When steam is passed over the red-hot iron, magnetic oxide of iron is formed. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Reaction with chlorine. Iron combines with chlorine to form ferric chloride. 2Fe plus 3Cl2 gives 2Fe3Cl. Reaction with acids. With dilute HCl and dilute H2SO4, it evolves H2 gas. Fe plus dilute 2HCl gives FeCl2 plus H2. Fe plus dilute H2SO4 gives FeSO4 plus H2. With concentrated H2SO4, it forms ferric sulfate. 2Fe plus concentrated 6H2SO4 gives Fe2SO43 plus 3SO2 plus 6H2O. With dilute HNO3 in cold condition, it gives ferrous nitrate. 4Fe plus dilute 10HNO3 gives 4FeNO32 plus NH4NO3 plus 3H2O. Depending upon the carbon content, iron is classified into three types: pig iron with carbon content of 2 to 4.5%, wrought iron with carbon content less than 0.2%, steel with carbon content of 0.25 to 2%. Uses of iron. Pig iron is used in making pipes, stoves, radiators, railings, manhole covers, and drain pipes. Steel is used in the construction of buildings, machinery, transmission, and TV towers, and in making alloys. Wrought iron is used in making springs, anchors, and electromagnets.
In this topic, you have learnt
24 karat gold is equal to pure gold. A mineral may be a single compound or complex mixture of various compounds of metals which are found in the earth. The mineral from which a metal can be readily and economically extracted on a large scale is said to be a ore. The process of extracting the ores from the earth's crust is called mining. Various steps involved in the extraction of metals from their ores as well as refining of crude metal are collectively known as metallurgy. The rock impurity associated with the ore is called gangue or matrix. Flux is the substance added to the ore to reduce the fusion temperature. Flux plus gangue gives slag. Smelting is the process of reducing the roasted oxide to metals in the molten condition. The chief ore of aluminium is bauxite, Al2O3 2H2O. The overall equation for aluminium extraction is 2Al2O3 gives 4Al plus 3O2. The chief ore of copper is copper pyrite. The iron is the second most abundant metal after aluminium. The extraction of iron from hematite ore, Fe2O3. Calcination is a process in which ore is heated in the absence of air. As a result of calcinations, the carbonate ore is converted into its oxide. Roasting is a process in which ore is heated in the presence of excess of air. As a result of roasting, the sulfide ore is converted into its oxide.